Let's go ahead and assemble the C-link. The new part, nope, assembly. I should have picked millimeter. Really shouldn't matter too much. We'll see it in the measurements, can adjust it later. We'll browse, and I'm going to pick up the C bracket. Origin is on the kind of the back left corner. So when we accept, okay, if we drop it anywhere in the work area, then we'll have to float it and put it in position. If I go to the OK, then it just aligns origin to origin and that current orientation. Let's go ahead and open up the link. And we did an example with the mate references for the demo, so I want to run through that process again. We can make however many mate references we need. So if I just come over here and let's see if we edit the definition. Nope. Properties. I can suppress, and then that mate reference won't participate. So I think that one was the edge. On this one, I'll go ahead and do a mate reference for, so typically would pick the edge because we want it to find coincident to a face and concentric to another circle. If I come back over here and I pick the cylinder, then we're just looking at concentric or tangent, and I can have it default to concentric. All right, so we'll go ahead and accept that one. Mate references folder becomes active, and default 2 becomes the current mate reference. So if we go back into our assembly and I insert component existing part in assembly, the link is open, and the advantage here is that when I place it onto any other cylinder, it's going to align that hole to the other hole, cylinder to cylinder. So let's go ahead and accept that one. So with concentric, it's still able to move up and down. With the cylinder selected, with the edge selected, it would be coincident to that face. So there are a couple of things that you'll need to be aware of. All right, so several of the mates, let's go ahead and do the coincident mate that we would have gotten with the edge. All right, so select, control select, and pick coincident. And if I want to see what, we know that this is 10 millimeters and the opening is 20 millimeters, 787. So let's go ahead and switch it back over to millimeters, grams, and seconds. Is 20 millimeters. And then we could suppress the coincidence, still going to be able to rotate. So managing the suppression on those features, if I select, control select, then we could go distance, and that would be 5 millimeters for it to center. And if I suppress that one out, then in the mate reference tool, we have the standard mates. We've been doing a lot of coincident, concentric. We'll see what tangent does here in a little bit. Cam and slot are probably slots the most useful, and the screw being able to see the geometry rotate through, as if you were tightening or loosening a bolt or a screw. So with the profile center, that would take this calculated center of this face and align it to the calculated center of this face. It's a quick way, but it's not always the best way. I like to do the holes centers to hole centers. If there's a mismatch, if a dimension changes, if anything kind of goes wrong, it's an error checking that you probably won't find or be able to distinguish in the model. So with the width selections, we pick 2 faces on one part, 2 faces on another part, and then when we accept it, it will stay centered. So if this grows or shrinks, this will still stay in the center position. Let's see, what other one did we have? Let's go ahead and suppress, and then select, control select, we have a limit distance and the angle and limit angle for our geometry. Right now, current position is 5 millimeters. Maximum position for it before it runs into the other side is 10 millimeters, and minimum would be 0 millimeters. So we can go ahead and accept that, and then that gives it a range to move through so that we can kind of simulate the motion, and if there was something that needed to contact with the other screw, that would help us to visualize it. All right, so let's stay with the coincident. And if I unsuppress it, these two aren't necessarily in violation. They're not working against each other, but this one's no longer, pretty much in effect because the coincident says it's within the range, but you're not moving. All right, so I'm going to go ahead and turn off the origins and said that I would suppress the concentric. And what I'm looking for is we'll rotate over to where we can see the through holes. And I'm going to make that tangent. So with a bore that big in the link, that's really going to, maybe from the top, that's really going to show us the range of motion and how much this can sort of flop around. So the limits, the positional limits of the link, if it gets far enough back, it's just going to contact. And if we use the move tool, move component, I can look for collision detection. So we want to go between these two components, link and the C bracket, and when I resume drag, when it contacts, those faces will light up and say you are in collision, or if you went any further there would be an interference. And we can use that as a tool to access the geometry to kind of error check the locations. All right, so select, control select, we're going to look at, I got my clicks here, select, control select. If we go parallel, then this is going to allow it to move in the tangency. And if I wanted to, I could set up a configuration for each one of those to explore that solution, but not really looking for anything particular here. So just to run through the mates, select, control, select the face. I didn't get the pop-up that time. Maybe I'm clicking too fast. There they go. All right, so an angle, we can set it 30 degrees. And we can go ahead and accept, and it'll still move in the tangency, but at 30 degrees, sort of like the parallel to whichever face. And then the limit angle, try not to click too fast through that. The limit angle says between that face, and we kind of want to pick a face maybe a little bit, make a selection a little bit better. This one's going to be 0 degrees to 90 degrees. If I were to go from the inside face, then set the limit angle from 0. Oh, current is 120. So if I were to set it from 180 on the max, and I try to keep the numbers consistent, and to 0, then that will give it a range, even with the tangency and the interference, that it won't move past that that face in those directions. So let's go ahead and suppress the tangent, unsuppress the concentric, and this gets a little, does get a little confusing as you're going through the process. And for instance, since the parallel is in that range, if I unsuppress it, it shouldn't generate an error. And really, a lot of these probably won't generate an error until I get to something that is really going to have a direct conflict. So tangent and concentric are not something that can be solved. So we'll suppress those out. All right, so just a quick overview of our mate references. Let's go ahead and insert the component. I'll do an existing part and browse this time. We'll bring in the M10. and place it. And I'm going to pick, so select, control select, we're going to be concentric. And then we can maybe go with a tangency even with the planar face. So the arcs and the planar to an arc would both be tangent solutions. So if we're still in the tangent and this is moving around, let's look at that as an example. So you need to find the link, and we'll go ahead and suppress our concentric, unsuppress the tangent. So as this moves around, finds its range, then we would see that locking pin or that that screw be able to control or update the geometry. So the link is still able to move. Thought I unsuppressed. We got tangent, and then tangent to the face. It was looking for parallel. There we go. So it'll kind of move in that direction, and that's really our only indication of the collision interference. All right. So the other reason then that this one is able to move is, or has the minus sign, is because the concentric is able to rotate. So if we see the lock rotation, we can locate it, or if we know what's going on with the minus signs, we really don't have to do anything with those. So if I want to go to the File Explorer, let's see what is open, the C bracket, the link, the M10. All right, so I don't have those available. To grab the 12, so we'll go Insert Component and Browse. So if it was open or as part of the assembly or the drawing somewhere else, then it would be available in that list. All right, and then select Control Select, Concentric, and we can check with the cosmetic threads about where that's going to line up. So if I were to make those coincident, my concern here is that with the thread length, we might want to shallow that up a little bit so that when this seats, when it goes to the bottom of the threads to that face, that there's clearance here. It depends on what's underneath this, that we don't really want this to act like a jack and start lifting up the part. All right, so we'll go ahead and save this. And we can do the C-Link assembly. And we want to prepare for our drawing by doing the exploded view. So new exploded view. Let's go ahead and bring the pin out in one direction, 80 millimeters, maybe we'll make that 75. And then the other pin, we'll grab the arrow and bring it out, maybe 50 millimeters, and done. And the link, bring it out some distance, probably 50 millimeters as well, and done. All right, so when I save this, now I have the assembly configuration. Just Control S to make sure everything was updated. And we can see about the explode, collapse, and just notice that the hole, because of the thread engagement, and we're on the minor diameter, this isn't truly representative because it can run into that part. And again, those are only visual indicators that you're going to get that there is a collision. So my tangency, instead of tangency to that that threaded hole, I may want to make it tangent to the post. So if I edit the feature, we can remove the face from the C bracket and change it to the screw. So when it runs into the threads, that's as far as it can go. And now we're not seeing that line kind of fade in and fade out. All right, so mention it again, you don't need to save a separate assembly file. It kind of it doesn't do anything, and we really need this to just this one file to manage our geometry. So make sure that's saved, and we'll be ready for the drawing.